Welcome back to the series of lectures for microprocessor laboratory. In this lecture, we are going to see the assembly language programs for sorting operations. So, we are going to see the sorting of the given set of numbers in ascending order as well as descending order. In this process, we will try to find the largest number in the given array and the smallest number in the given array. So, in this experiment, we are going to deal four programs. One is the ALP to find the largest one, the second one ALP to find the smallest number in the given array, third one assembly language ALP to sort the given set of numbers in ascending order, then ALP to sort the given set of numbers in descending order. The algorithm what we are going to implement as an ALP is a bubble sort. It is otherwise known as exchange sort. Okay, it is a very simplest algorithm, sorting algorithm, which works repeatedly stepping through the list that is to be sorted out. Okay, it compares two items at a time and swap them if they are in the wrong order. The pass through the list is repeated until no swaps are needed, which means the list is sorted out. The algorithm gets its name from the way the elements are bubbled to the top of the list via the swaps. Because it only uses the comparisons to operate on the elements, it is a comparison sort. This is the easiest comparison sort to implement. Okay, and first we will see the ALP for finding the largest number. Okay, and this is a given program, and as per the program we will analyze how the things are going to be sorted out. And the next program is the smallest number. A small change in the program will be done for extending our program from largest number, ALP for largest number, to ALP for smallest number. Now, without wasting time, we will go to the analysis. Okay, so first we are going to define our data. We are going to define our data in a data segment. Okay, so the first part will be first define two logical segments, that is code segment and data segment, for writing the code and accessing the data. Then initialize the data segment with the data that has to be sorted out. Okay, since our program is in finding the largest number, okay, so take the array of numbers out of which you need to find the largest number. Okay, so in our data segment at 1000 location, from 1000 location we have defined the list of numbers, okay, in terms of bytes. Okay, means means in terms of 8-bit number. So the numbers are 5, 6, 3, 2, 9. Okay, so that is being reflected here. So in 1000 location 5 will be stored, 1001 location 6 will be stored, 1002 3, 1003rd location 2, and 1004th location 9. Okay, and we are closing the data segment. Okay, then we are entering into the code segment. We are initializing the code segment, and right from org 2000h we are writing the code. Okay, and first step is we need to access the data segment in the code segment. So what we have done, move ax comma data, move ds comma ax. Okay, then what we need to do is we need to define the number of comparisons we need to do such that we will get the largest number in the given array. So here, if the number of elements are n, the number of comparisons we need to perform is n minus 1. So how many numbers we have taken? 1, 2, 3, 4, 5 numbers. So here we are taking n minus 1. So we can write it as number of comparisons required. So which is equal to number of elements minus 1. Okay. So then wrap the tab, right? So number of comparisons equal to number of elements minus 1 for one sorting process. Next, what we are doing, move si comma offset list. So what it will do, si will be pointing to the starting address of the list. So this is our list. Okay, and this is number of comparisons. Okay, so the number of comparisons will be 4, and here we can write one more thing. Okay, so we can write the number of comparisons, right, and the number of elements are so number of comparisons here. So for every pass we are going to check. Okay, so number of elements are 5. So what we do, we will insert one okay, so here we will write number of elements. So number of elements are 5. Okay, so the number of elements are 5. Number of elements are 5. So the number of comparisons we require is 4. Okay, so that is stored in a counter register CL. Okay, then si is moved to the starting location and the first element is moved to AL. Okay, so now what I do is I will remove this part. So nowhere we require this. So I am just deleting it, and the rest of the program I am going to show for you. Right. So first is the content that is present in the address location pointed by si is simply copied to AL register. So this is the content that is present here. So copy it and store in AL. Okay. Now compare, in the next step, compare AL comma si plus 1. So si is 1000. Okay. Si plus 1 is 6. Okay. Now what we are doing, we are comparing 6 with 5. Okay. So there is a first element that we are moving to AL register, and the second element is 6. So these two, 5 and 6 are going to be compared. Okay. So since we are finding the largest number, okay, the largest number has to come at the top. Okay. So what we do is, so comparison operation is the subtraction operation between the two operands. So AL value is 5 and AL value is 5 and the next element is 6. So 6 is going to be subtracted from AL. So obviously both are not equal. So zero flag will not be set. Okay. So if 0 flag is not set, then the next one is, it will see which number is larger. So that larger status we are going to find with the help of carry. So if the second operand is greater than the first operand, we are going to get the carry. Okay, so now in this case we are checking if we are having the carry. Okay, so if we are having carry, okay, we are going to exchange the elements between these two operands. If no carry is there, the meaning is AL content is larger and that will be compared with the next element. Okay, so what we do is Si plus 1 comma AL. So Si plus 1 is 6 and AL is 5. So there will be a carry generation. So JNCL instruction will be false, and then what we are doing, we are exchanging the elements among AL and Si plus 1. Now AL value is 5 and Si plus 1 is 6. So now simply AL will become 6 and Si plus 1 will become 5. Okay, so Si was so this is the first exchange. Then what we are doing, increment the value of Si. So now Si is pointing to the next location. So here one comparison we have done. So CL value will become 3. Okay, so CL value will become 3. Next, JNZ L1 means CL value, if it is not 0, again what we are doing, we are moving to the location called L1. So L1 is pointing to comparison. So L1 what it is doing, now compare the value of AL, that is 6 comma Si plus 1. Now Si value is 1001 and Si 1001 plus 1 is 1002. So now 3 and 5 6 are going to be compared. This 3 and 6 will be compared. Okay, now when it is compared, 6 comma 3. So 3 is the smallest number, so there won't be generation of the carry. Okay, so immediately this condition will become true. So jump for no carry. If carry is not existing, we are going to jump into this location. So there is no exchange here. Okay, so now we are jumping to the location called L1, right, and so to L. So again Si value is going to be incremented, means Si will be pointing to this location 1002. Okay, and decrement CL. So two comparisons are over. So now the comparison is 2, CL value is 2 and CL is not 0, again we perform the comparison. Now the comparison will be between AL, that is 6, and Si is 1002 plus 1. So 1002 plus 1 is 1003. So 2 is compared with 6 and obviously 2 is the smallest number, so no carry generation will be there and this condition JNC will become true, and again Si value is going to be incremented. Now Si is pointing to the 1003 location and CL becomes 0 1, and since it is non-zero, again we are performing the comparison operation. So the comparison operation, AL comma Si plus 1, AL value is 6 and Si is 1003 plus 1004, it is 9. Okay, so 9 is greater than 6, so obviously a carry will be generated. So JNC comma L, this condition will be failed and there will be an exchange that will be occurred. So now in 1004 location it will be 6 and in AL it will be 9. Okay, so once we perform the exchange operation, now Si is pointing to the next location 1004 and we are decrementing the number of comparisons. Now the comparisons has become 0. Okay, so now the comparisons has become 0. Now what happens here, this condition will fail, and where is the largest number that is present? The largest number is present in AL register. So what we do, that AL register value we will move to some address location 3000. So identify the new address location, say some 3000H, So let us consider this as our 3000H. Okay, so now SI is pointing to the new location as 3000H. Into this location we are moving the value of AL. Okay, so now end the program with int03H and end the code segment end as and end the start. Okay, so this is for finding the largest number. Okay, so by doing a small change, so here we are checking for the largest number. Okay, so if you want to check for the lowest number, okay, a small modification we need to do, that is we need to remove n, means we need to check for the carry. So if no carry is there, perform the exchange operation. Okay, so here, so when we compare these two numbers, that is AL comma SI plus 1 minute students. So here the comparison is performed between AL and SI plus 1. Okay, so if AL will store the smallest number. Okay, so when there is no carry, we are performing the exchange. If we are having a carry, okay, so we are directly going to the next location. Okay, so let us see this program in the DOS prompt. Since I have already written the program, okay, so we'll straight away go to the program. So first is mount C colon 8086 C drive, edit. So I'll go for the largest number first. Open the largest segment program. So the same program I have written here. Okay, so exit Amazon larg.asm. So with this the object file will be created. Now link the object file so that we can get with the library functions, so that we can get the execution file. So it is free from errors. So directly go for debug large.exe. So unassemble the program right from 2000H. So this is a location where we have started writing the program. So 2000H, our program is there. Okay, so try to check your data. It is present in 1000H. So this is our data. Now execute the program. So once you execute, the largest number should be present in AL register. So see, in AL register we have 09. Okay, so now this largest number you have sent to 3000 location, you got 09. See, this is one way, right? So if you want to give a new value into this, okay, we can sort it out like 076A colon 1000H. So let us say 06 FF 1 2 3 4 5 numbers we have to give. So we will give 9 now. Okay, so now execute the program right from 2000H. So FF is the largest number. Display 3000 memory location. You will get the largest number here. Okay. Now, if you want to do the smallest number, the opposite way. So only small change we need to do. So what is that is 1. small asm. See here, so the program is the same program. The only change what I have done is, instead of JNC I kept JC, jump on carry. So if you are getting carry, don't do the exchange operation. If you are not getting the carry, then perform the exchange operation. So NASM small dot asm. So create the object file. Okay, so if it is free from errors, and link the program obj. Okay, so straight away I'll get the no stack. Next debug small dot exe. So unassemble the program. Okay, the same program. So if you want to see the data, a colon 1000h. So our data is there. In this smallest number is 02. So this 02 has to be present in AL register. So 02 we got. Okay, and display your memory also. In the memory also 02 should be there. And let us give a new value. Edit 1000. Okay, so let us give 01 45 00 23 56. Okay, so in this the smallest number is 00 in this given new set of numbers. So start executing from 2000. So now see 00 is loaded in AX. Okay, so this is how we will perform the smallest and largest numbers. Okay, so in the next lecture we will see the sorting of numbers in ascending order and descending order. This is the first pass. So there we are going to perform n minus 1 into n minus 1 comparisons. Okay, so that the sorted list will be coming. So here we will be using 2 loops. Okay, so that we will do in the next lecture. Thank you.